필요해.
So thank you again for coming to room 2, to this cozy, nice room. Is anybody there? Have a look. Don't believe so. No one there. So please come in. My name is Michael. I work for Facit Digital. We are a user research company from Munich. And recently, many of our clients approached us with the question, how can we make good use of novel user interfaces? For example, speech input, so that's voice control, gesture input, touch devices. And that's not such an easy question, and I'd like to share with you today some of our experiences that we made recently. So this is where our offices are, in central Munich. But more important, we are part of UX Fellows, which is a user research network in now 27 partners. And the nice coincidence is that our latest new entry, the 27th partner, is the company that organizes this great conference. It's UseLab. I'd like to talk to you about natural user interfaces. So, what are these monkeys for? You're asking. So, I just wanted to show you a holiday picture, but it is maybe it's a good image because natural interfaces have the potential that it can be used even probably by monkeys. And I actually just needed a picture with some picture on it. There is, when we talk about user interfaces in general and the development of user interfaces, there is quite a popular development model which begins more or less in the 60s. Probably you've heard of that. So when computing began, with terminal computers began, or in the 70s, they were used with command line interfaces. Command line interfaces could only be operated by experts. You really had to learn all of the commands in order to be able to use that computer. So the operation of these old school computers was based on learning and on recall. You had to actively recall what was the order again for I don't know, for printing or for doing anything. It was really in the mind, and it was limited to expertise. When graphical user interfaces came up in the 80s, that was a real revolution, because also non-experts could use these computers because they could just explore them. They could see what possibilities they were offering without a prior learning without prior visiting of computer courses. And one of the tools that were used for achieving this was the use of metaphors. And most of these metaphors were drawn from the office environment. For example, the trash bin. So it's quite intuitive that if you drag an object on the trash bin, you will delete it. So this is something that you know from the office. If I throw something into the trash bin, it will be deleted. So the next day somebody will have brought it away. So that's a metaphor. And these user interfaces allowed exploration. You could just see, okay, what is this computer able to do? And the psychological mechanism which underlies this is recognition. So recognition, as opposed to recall, is in most of the cases easier because you don't have to actively recall something. You can just see, okay, here's a list of commands, okay, I remember that, so that was the right one, I just pick it. Some say that the next step in this evolution are natural user interfaces. I will define these a little bit more in detail afterwards. So natural user interfaces, in contrast to the other ones, rely on natural behavior, something that you would do in everyday life. For example, like grabbing an object or shifting something around or so. So these user interfaces try to make use of your spontaneous behavior, and thus you can use your intuition to have a dialogue with that system, and you don't have to necessarily rely on a metaphors, for example. So this is Steve Mann. Steve Mann has coined the concept of natural user interfaces or direct user interfaces already in the 70s and in the 80s of the last century. So Steve Mann, he's done a lot of research with wearables, as we can see, and I don't know him personally, but I assume he's an interesting person, so you find many funny pictures like these on the web from him. As I said, he was very much into wearables, but there are also other kinds of natural user interfaces, for example, as speech input and output, gesture interfaces where you can use your natural gesture behavior which you use in everyday life, touch, of course, and also immersive user interfaces, just like the new Oculus Rift, for example, where you really immerse yourself into new worlds, into virtual worlds, and interact within them. Natural user interfaces promise us a lot. Many of them are almost invisible. You don't have any mice, you don't have any keyboards anymore. Sometimes you don't even have a screen, so you actually don't see many of them. So, for example, voice input output device is sometimes not even visible. You don't have to learn how to tackle artificial control devices. So, for example, my mother-in-law has just learned how to use a computer mouse, and then I just couldn't believe how difficult that was for her, because it's just so natural and just a natural behavior for us. Natural user interfaces are often simplified as compared to classic computers. If you have a look at the iOS or at the Android operating system, you can see that many options have just been left out in order to simplify the interaction with those systems. And this enables us just to try them out. So the danger or the fear of doing something wrong, of destroying the system, so to speak, is much less than with classic computers. So interaction is really a natural thing, and you have a steep learning curve. So even your grandmother might be able to use an iPad, for example. So who has given an iPad to their grandparents or parents, or seen them interacting with it? It's really amazing to see. So we just did that experiment, my wife and I. So my mother-in-law, she got a classic computer, and my mother got an iPad more or less at the same time, and then we could really observe who of the both was dealing better with the device, and of course the iPad won that battle. There is some controversy though to new natural user interfaces. They are not intuitive per se, so that means there are still some cultural conventions underlying. So, for example, if we take the edge swipe gesture, which is in the new iOS, where you can go in the Safari, for example, if you want to go backwards in your browsing history, if you use the edge swipe gesture, that's a convention. You have to still learn that it's the same thing as learning to draw an object on the trash bin. We still need to abstract and transfer metaphors from the real world to the machine. So, for example, we have to understand that metaphor said that if we pinch a photo, that it gets larger. So try that with a paper photo. It's impossible. It won't get any larger. If you remember the model, so I said the model assumes that there's a processor. So first comes a command line, then comes graphical user interfaces and natural user interfaces in the end. So NUIs and GUIs are not really mutually exclusive, because many of the so-called natural user interfaces, they still rely on graphic representation. So take all the touch stuff, take many of the gesture applications, they still have a graphical representation which they need, otherwise they wouldn't work. So as regards to the model is not really mutually exclusive. And then this is a question that I often ask myself: is it really so unnatural using a commonplace Windows icons menu pointer user interface like the classic computer is? So probably it's pretty natural as well. So I assume that many of the nice presentation decks that we're getting to see at this conference are made with classic computers with a mouse and a keyboard. Let's come to the aspect of voice input and output. So voice recognition has started, companies have started experimenting with that in the 60s. However, the calculation power was really low at that time, so the results weren't really promising then. So the first usable systems came out in the 80s actually. Many of them were automatic response systems and telephones. So we have dictation, speech to text, which actually works since the 90s. And in the recent years, we have seen many applications like automobile navigation systems that can be operated by speech. On the little helpers like Siri, which came up in 2011. And it was actually Siri that made one of our clients think, which is a major German car manufacturer. It made them think, how about putting a car configurator on a mobile phone, which is completely operated by voice input, voice output, because it was really fashionable at the time. So I don't know if any of you has already tried out a car configurator. That can be a really complicated thing. So many options, many possibilities that have to be combined. And our task was to find out if that really made any sense. So we asked ourselves, what do we actually know about speech? And there was some, after a little research, we found out that that our auditory system processes information much more slowly than we can scan text or images with our eyes. Then, however, humans talk faster than they can type, usually. Another thing is that speech by itself is fleeting. So probably you have already forgotten what I said 5 minutes ago. So that's an inherent problem which we have with speech. So it is not really well suited to large amounts of information. And so likewise, it's difficult to explain all the possibilities and functions of a complex system. And unlike as in other popular touch interfaces, we don't have any widespread conventions how to use voice input or output yet. So there's no convention how to say, okay, now I want to dictate something, now the dictation stops. There's no convention about triggering commands and so on. There are some implications for user interfaces. That is, firstly, if we have large amounts of data, we better rely on vision than on speech. However, speech recognition could be more efficient for large text input if we can avoid typing. And voice output, on the other hand, should be limited to very brief prompts and confirmation. Otherwise, it could become very quickly inefficient because long text just take long time to be read. And the user, that is important, the user must know what is the possibility, what is the room for possibilities of possible commands. And this problem is similarly as the problem that we have with the command line interfaces. You just have to know what the system can do. So good applications for voice could be extremely large lists from which the user has to pick up one item. I'm going to show you an example right now. And another good application could be recurrent voice commands, where you always do the same things, however, and you just know them. So in user interfaces for experts, mainly. Where do you want to go today? That used to be the claim from Microsoft and back in the 90s. And it would be a good question to ask a railway traveler who wants to go to Woermann. How is that spelled? Does anybody know where that is? No. Okay, so it's very little. It must be a very little town. I like the picture. So assume there are 10,000 train stations in Poland. If you are the person who wants to go to this village, you know where that is. So an acoustic, a speech system could just ask you, where do you want to go today? And you say, okay, I want to go to Riest, you know. And in that way, you could just jump over many, many steps in the user interface. So that could be very efficient to pick up from a large list. I know that I want to go there from 10,000 possible stations. Similarly, that could also work well with search engine, because what can you do with a search engine? Anything. And the user knows that. So I can put in anything. So that's why speech recognition works well for search engines. Not so well does it work, for example, for this example. This is another client of ours whose name is completely different, but their idea was, okay, why don't we just put a blank page there, which operates with voice, and we just ask the client, how can we help you? What do you want? And so it's quite easy to answer that question. It wouldn't work because nobody would know what are the options, what does this bank offer, what does it make special. So and then people probably don't even bring the engagement to talk with that application. So you have to act in another way. So voice control at any price, no, and no was also the answer to this car manufacturers. So they just got this idea. So these two are not nurses. These are my colleagues, Eva and Katrina. So it's a picture taken just the other day. They are just right now they're in a hospital in Munich, and they are observing nurses how they use a blood glucose measurement tool. And the question is, what is the usage behavior? What are recurrent commands, recurrent functions, and where are possibilities for a boost in efficiency? And in fact, in healthcare is a very interesting sector for voice and gesture input, because one issue is disinfection. So all of these tools are exposed to blood every day. So they have to be disinfected, but not only blood, but also the people that touch this is a touch interface, and it gets touched very, very often. So if one could reduce the amount of touching on that, you could, for example, use other materials, lighter materials, that because they don't have to be disinfected so often. And then on the other hand, this is already one finding, so there are very many recurrent commands in which the nurses have to choose and pick from menus that are very hidden in a hierarchy. And if all these nurses know which commands they would use with each patient, they could use voice instead, and that would be a real efficiency booster. However, there are some concerns about privacy, of course, and of course acceptance. So we're just looking into that. Let's talk about waving. That is freehand, three-dimensional gesture input. Last year has been really the year of freehand gestures. So we have seen many new devices coming to the market, gaming consoles, lead motion, mobile phones that could recognize gestures, but also televisions. So it's still a big topic, and we're doing a lot of research into that. Could you please start the film? So this is an example for a three-dimensional camera that Infineon has developed. Infineon is a semiconductor manufacturer. They're not selling these things to clients, but to OEMs. And the specialty of this one is that it cannot only recognize two dimensions like a normal camera, but it can also measure the distance of, for example, your hand from the computer. We did, some time ago, with a very rough prototype of that, we did a gesture alphabet test, because one of the tasks was to replace touch operation, in this example of Windows 8, with freehand gestures, and it's not that easy because you have to replace any gesture, any two-dimensional gesture with a three-dimensional gesture. But we also tried to find out which could be killer applications for that third dimension. And, this, for example, was one very good application. So it's really fun to play this game with free hands without a surface. In the end, what I can say here is that this is really great technology, but there's really still many questions to answer. So we found out in this study and also in other studies that gesture control is really embraced by potential users. They say freehand gesturing is really cool and appealing. It's not only like because everybody thinks of Minority Report, and I don't think that we will be waving just like Tom Cruise was with all of his arms and everything, but users typically find this very attractive. However, we still have to find out which are really the so-called killer applications for the third dimensions, where we really have advantages in efficiency but also in joyfulness. Which gestures go beyond touch replacement, because if we only replace what is already there in two-dimensional systems, we don't have any added value. And of course, we have to find out which are the most suitable devices. So we have here an all-in-one computer, like this big one, but it could also be televisions or tablets or anything else. Of course, when you have the third dimension, you have also ergonomic questions. Like I said before, I don't believe that anybody could stand that work that Tom Cruise was doing with Minority Report more than 5 minutes, because he was really waving with all of his body, more or less. So, and we also had that in their tests. So in the end, people were relying on little boxes that could be placed under the hands, because it was just too hard to do all these gestures. This is an example of the challenges that you have with the third dimension gesture interface. So a click is very easy, and a tap is very easy if we have two dimensions. If you want an analogous function in open space, you have to really be inventive. So these are some possibilities that there are, and we're doing a lot of research now into how the two-dimensional gestures can be translated into three-dimensional gestures, but also with an added value. Can you please let the film play? Okay. So this again is Katharina. This is Katharina who shows us pointing gestures. This is an important distinction that we have to make. Pointing gestures can be in open space, but she's just pointing, as you can see, at buttons, and she is using a very commonplace mouse cursor. So this is a very simple way of replacing a two-dimensional user interface with three-dimensional. And as you can imagine, the added value is quite limited. On the other hand, we have semantic gestures. Semantic gestures have an associated meaning, so they are able to transport more information at the same time. And we all know them. For example, any Mac user knows these gestures. So if you swipe with all 4 fingers upwards, you can launch mission control and everything. So this is again something you have to learn, but it's semantic, so there's a meaning in that gesture. But when semantics come into play, culture also takes a role, and this is really an issue, because we have to be aware that maybe local cultures influence with semantic gestures, and also maybe some cultures are more inclined to use gestures than others. And most of these products are marketed worldwide, so this is a really legitimate question to ask as a manufacturer. So again, I have another film. So before we start this, now you're going to see different persons, all from different countries, who communicate the same thing. So we found this out with a study with UX Fellows, with our colleagues from UX Fellows. And just have a look at it and try to figure out what they are trying to telling us. Okay, let's go. Can you play the movie, please? I think it won't be working. I'm really sorry because it was really nice. It was really nice. Okay, I'm gonna skip this. I can't do that quiz now. So as I said, we did this study in 18 different countries around the world with our colleagues from UX Fellows. And what we did was we just set people in front of the television, which was switched off, and we just told them, okay, just imagine that this television was able to understand all of your gestures. And we asked them to control that device only with gestures. So that, and the commands were just very typical commands, just like put up the volume, put it down, change the channel, call the EPG, or share your content on Facebook, for example. And what we found was that out of 18 different countries, some of the commands were the same. Spontaneous commands were the same across all these different countries, across China, Korea, Argentina, and so on. So, and this is, for example, volume up, volume down was the same spontaneous gesture in all of these countries. Or pause a program, pause a VOD was the same. But however, there were also many other gestures that were really different between the countries and also different between neighboring countries. For example, between the UK and France, between China and Korea. Very different way of spontaneous gesture behavior. And if you are, for example, Samsung or some other TV manufacturer and you want to implement such a system, you really have to take that and bear that in mind that even neighboring markets can be very different. Okay, one last thing. I'd like to talk about touch interfaces just as well. What do you think? So here on the left we have a regular tablet with remote control app, which works with Samsung in this case, and you have a regular normal remote control for Samsung as well. Which one of these two is best for zapping? Is it A or B? B, yes, of course. B is correct. And which one might be good if you want to find a nice film from an online library? Yes, that's A. So this is one of our, okay, this is quite self-explaining, but it's an important finding from one of our studies that we did recently. We did the Smart TV Ethnography and went into 25 early adopter households with smart TVs, tablets and everything that had all the technology at hand, and we were trying to understand what is their spontaneous behavior, their media usage behavior. And to make it short, we found that if a person has many screens at home, there are quite clear preferences what to do on which screen. For example, I would just pick up one. Zapping, as I said, is done predominantly on the classic remote control, and picking up complex films or searching an EPG and planning your television week is being done on tablets and on secondary devices. And these make use of their inherent qualities of these two methods. So one last question, because I have to close now. Who of you does not use Twitter? Oh, so many. So, but still some Twitter users left, so I have a special service for you because before I close, and I already thank you for your attention. So if anyone wants to tweet about this, I already wrote it down for you. Thank you very much.